Morning, guys. Can you hear me?
Morning, sir.
Hello.
Yes, sir.
Hello.
Yes, sir. Good morning, sir.
Hello.
Yes, sir.
Yes, sir.
Can you hear me?
Yes,
Yes,
sir.
sir. Yes, sir.
Yes, sir. Yes, sir.
PowerPoint presentation is visible.
No,
No,
sir.
sir.
No, sir.
PowerPoint.
No, sir.
Not visible, sir.
Now?
Yes, sir. Visible.
Yes, sir.
Okay. Just another 2 minutes. I'll start. 1 minute. So in the chat, please enter your USN numbers. Can you hear me? Hello. Hello.
Yes, sir. Yes, sir. We can hear, sir.
Audio is visible.
Yes,
Yes,
sir.
sir. PPT is visible. We can hear also,
Everyone,
sir.
please enter your USN numbers on the chat. Okay. If there is any doubts, just stop me the presentation and you can raise your queries. So I'll start the model 2 continuation. So it's a three-phase induction motor. It's a review only. So as per your syllabus, actually the slip torque equation, torque slip characteristics covering motor generating and braking operation and maximum torque, significance of slip has been assigned as per the syllabus, but he has given the review class. So just it's a review. So no question will be asked on this topic. Whatever the slide today I'll be sharing on you. So well, coming to the construction of a three-phase induction motor. So as we know that AC motors in a most required. Okay, so which will be converting from electrical energy to mechanical energy. So as we know that most of the supply which is available is an alternating current. Okay, so based on that, most of motors which will be available in industries are induction motors, so which have been widely used. So based on this, let us see how the construction and working of a three-phase induction motor is been carried out. Already this has been studied in your first semester. Okay, so just it is a brush up class. So according to the construction, we know that it is having two parts. So one is the stator and the rotor. Well, coming to the stator, so it consists of n number of laminated plates. Okay, so while coming to the second slide, so we can see here, so it is having a number of laminated plates, so which is of 0.4 mm or 0.5 mm thick to reduce the eddy current losses in the stator, and the n number of laminated plates are framed so that it comes as a stator core. So the stator core has been cut at the inner periphery of the stator, so which forms the stator slots where the windings has been framed. So windings will be framed in such a way that since it is a three phase, so three windings will be framed as R phase, Y phase, and B phase. So that considering as a three phase system. So each winding has a phase displacement of 120 degrees. Okay. So the arrangement of windings will be of 120 degrees. So if you see in the diagram, so A and A dash is been considered as phase A, and phase B. So from A to B, so it is having a phase difference of 120 degrees, and similarly C, which is having another phase displacement of 120 degrees. So between A to C, the phase displacement will be 240 degrees. So this is how the windings will be carried out in the stator diagram. So let us go for the rotor. So rotor, again, it consists of a cylindrical laminated core with n number of parallel slots. So where the conductors has been placed in these slots in the form of aluminum or copper bars. So the rotor has been shorted at the both the ends. So that are the end rings, so that there is no any external resistance which will be added in the rotor slots. So where it will be running as a constant speed induction rotor. So if you see the rotor slots, so the rotor slots are slightly skewed. So this arrangement is because to reduce the magnetic hum or the noise, and to avoid the staling or to avoid the locking tendency between the stator and the rotor. So these are the rotor bars we can see which has been slightly skewed. So this is the construction with respect to the stator and the rotor. So similarly, while coming for the working of a three-phase induction motor, so generally it works on the principle of electromagnetic induction. So based on the law, so whenever there is a three-phase supply which has been connected to a star connected network, so that means, so if you see in the stator, so the conductors phase A will be placed in the first slot, and similarly based on the calculation, so the second phase will be placed in the B slot, and the third phase will be placed in the C slot. So which will be framing as a star connected network, or it can be a delta connected network or a winding. So based on this, so when a three-phase supply is been given to the star connected winding, so the rotating magnetic field of constant magnetic field will be produced. So that means the flux will be produced in the stator conductors. So that flux which has been produced is nothing but the maximum flux. So generally, if you see the flux which has been produced in a single phase induction motor is maximum flux, which is 5m. But what is the total flux which has been produced in the three-phase induction motor? So it will be 1.5 times the maximum flux. So when this flux flows in the stator conductors, the rotating magnetic field which will be producing a synchronous speed called as Ns. So that is the synchronous rotating magnetic field. So which will be formed as Ns is equal to 120 F by P. So where F is the frequency of the supply and P is the number of poles. So with respect to this, the synchronous speed or the rotating magnetic field which will be formed in the stator, so that links with respect to the rotor conductors. So now as the flux sweeps across the rotor conductors, then the flux will be cut between the stator and the rotor. So the EMF will be induced in the rotor conductors. So that EMF is called as the electromagnetic induction comes into consideration. So with respect to this rotor flux, the produces the rotor current. So the rotor current experiences a force, so which will be producing the torque. So during and the motor will be starts rotating. So with respect to this, the rotor starts rotating and tries to catch the synchronous speed, that is ns, but it fails or it slips at that particular point. So that's why the name comes as the slip into consideration. So now how let us see how the AC supply has been carried out in the windings. So in the stator windings, the line current with respect to the three different phases, that is the current with respect to R phase, Y phase, and B phase will be flowing in the winding. So which will be having a phase displacement of 120 degrees with respect to each other. So due to which the current will be produced. So therefore the flux which will be linked in the rotor, so that is the the flux which will be produced in the stator will be phi r, phi b, and phi y respectively. So if you see the waveform, so which is with respect to R phase, Y phase, and B phase. So R phase has been starting at the zero phase displacement, whereas Y phase is starting at the 120 degrees of phase displacement, and B phase will be starting at 120 degrees of phase displacement. So with respect to this, what will be the mathematical expressions for R phase, B phase, and Y phase? That is the flux which is being produced in the phase sequence. So will be phi r will be equal to phi m sine omega t, or sine omega t will be theta, and phi b will be equal to phi m sine omega t minus 120, and phi y will be equal to phi m sine omega t minus 240 degrees, or it can be omega t plus 120 degrees. So now with respect to these three fluxes, if we combine, so while rotating, what will be the total flux which will be carried out? The effective or the total flux in the air gap will be equal to the sum of all the three fluxes. So now if you see the vector representation, that is when considering the angle, that is theta is equal to 0 degrees or omega t is equal to 0 degrees, then the phi r will be equal to sine of 0. So will be 0. The flux at the R phase which will be produced will be 0. So with respect to B phase and Y phase, the flux which will be produced will be equal to root 3 by 2 into sine omega t, that is sine of 120. So similarly here minus root 3 by 2 into sine omega t. So totally if we consider the total flux, that is phi r plus phi y and phi b, so while calculating we'll be getting the flux as the 1.5 times the maximum flux. So this is with respect to the angle theta is equal to 0 degrees. So this will be our phase vector diagram which will be represented for theta is equal to 0. So similarly, when theta is equal to 60 degrees, so we can see the phase y will be having root 3 times of sine omega t, that is phi m into sine omega t, and phi r is equal to phi m into sine omega t minus plus 120 and minus that is angle is 0. So now with respect to this vector representation, so with respect to the mathematical expression, so phi r will be equal to phi m sine theta, and phi b will be equal to 60 degrees. So sine 60 minus 120 will be equal to minus 60. So here it will be, so 60. So one of the phase will be having 0. So R phase and Y phase will be having, so resultant flux will be 1.5 times the maximum flux. So similarly, when theta is equal to 120 and when theta is equal to 180 degrees, so this is how the vector representation will be represented. So whenever the angle changes, so we can see the total flux which has been produced in the stator will be 1.5 times the maximum flux. So this is how the vector, the rotating magnetic field will be taken into considerations. So now with respect to this as the phase sequence, so if you give the phase sequence as RYB, so the motor will be rotating in one particular direction. Suppose if we change the sequence, then the motor will start rotating in the reverse direction. So that's how the when the sequence changes, your motor rotation will be changed. So now why we have to choose the induction motors? What are the advantages and where the applications is being used? So if we go for types of induction motor, there are two different types of induction motors. So one is the squirrel cage induction motor and second is the slip ring induction motor. So if we see the practical applications, the squirrel cage induction motors are most frequently used motors. So why? Because the industrial applications are more compared to the slip ring induction motors. So squirrel cage induction motors, which are being used most frequently in industries, are in case of centrifugal pumps, in case of conveyor belts, so large blowers and fans, machine tools, lathes, and other turning equipments. So and also it is having more advantages compared to the slip ring induction motors. So while coming to the advantages, it is having a low cost, so it requires less maintenance. So because there is no brushes or slip rings, so similarly it having a good speed regulation, and it has having a better power factor while running. So it is having a high efficiency compared to the other motors. So small and lightweight motors will be available. So it is an explosion proof. So only the disadvantage is having speed. So we cannot go for controlling the speed of a squirrel cage induction motor. So that's the with respect to squirrel cage induction motor. So I'll come into the advantages. So we have seen. So it is having a high efficiency in converting electrical to mechanical energy. So while running or not during the startup, it is having a good speed regulations. So explosion proof. So similarly, while coming to the disadvantages of a squirrel cage induction motor, so as I told, the speed control cannot be done. So that is the one disadvantage. So second, it consumes more energy. So during the starting the motor. So and also the efficiency while running at full load current. So it is having less efficiency. So it is more sensitive. So while fluctuation comes into consideration when there is a voltage fluctuation. So during the surges, increase in voltage, the magnetic components of the squirrel cage induction motor, there will be saturation, and also it takes more current during the starting. So during the starting, it takes 5 to 7 times that of the full load current, and the torque will be of 5 to 1.5 to 2 times of that of the full load torque. So during the starting, so that's why that the disadvantage of or squirrel cage induction motor. So while coming to the slip ring induction motors, so this already we have seen in case of our lab, so which can be used as a starting of a three-phase induction motor, or it can be used for running the controlling the speed of a three-phase induction motor. So similarly, so that is the circuit diagram which will be represented where the stator is been separately connected to the three-phase supply, and the rotor is being connected to with respect to the slip rings, which has been mounted on the shaft of a motor. So where the external resistance is being connected to on the slip rings, where the resistance can be increased or decreased. So it can be used as a starter or it can be used for controlling the speed of a three-phase induction motor. So similarly, if you compare with respect to the advantages and disadvantages, so advantage here we can control the speed at any required level with respect to the slip ring induction motor, and the disadvantages are since we are using the brushes, so the maintenance comes into consideration. So it is a cost effective. So cost will be higher compared to the slip ring squirrel cage induction motor. So since the slip rings has been mounted on the shaft, the care has to be taken. Means a skilled person has to be recruited. So for maintaining the slip ring induction motor. So wear and tear, the brushes has to be replaced oftenly. So that maintenance has to be taken care. So like that, the say slip ring induction motor has more disadvantage. So comparing to the squirrel cage induction motor. So that's why in most of the applications we are using squirrel cage induction motors. So if you see the slip ring, squirrel cage induction motor. So this is the rotor where the rotor conductor has been skewed, and similarly we can see the another slide. So this is how the rotor bars has been connected, so which is not parallel to the shaft of the induction motor. So it has been lightly skewed so that there will be no much noise, and the locking tendency between the stator and the rotor can be reduced. So this is the review class. So just I wanted to engage for today. So tomorrow actually your syllabus will be started. So is there any doubts regarding the review? So this already would have been studied in your regular class. Is there any doubts? Hello?
No, sir.
Is there any doubts?
No, sir.
Okay, I'll end the session for the day. So tomorrow again at 9:30 we'll start the session, and the actual syllabus will be started tomorrow. Okay.
Okay, sir.
Yeah, thank you.
Thank you, sir.